example 4, we're solving a triangle. And so remember, when we're solving a triangle, we're trying to find the missing bits. The first thing that I would do is try to draw it. And I make kind of a rough sketch of a triangle. And I don't really know what's going to happen at this point, but I just kind of sketch it out to see what I'm looking at. This gives me angle B is 55 degrees and 40 minutes. 55.6 repeating degrees. Remember, 40 minutes over 60 minutes is going to give me that 0.6. I think we would be better in decimal degrees than minutes. So we would want to convert that. Side B is across from angle B. That's 8.94 meters. And then side A is across from angle A, 25.1 meters. Okay. Remember when we talked about Temple Run? And the guy running around the triangle or whatever? I see an angle and a side and a side. Okay? I see angle, side, side. That's the bad one, right? And that's going to indicate that this is case 2 of law of sines. Case 2 of law of sines. So I'm using the law of sines formula, but this is case 2. This is the ambiguous case. And so the fact that it's the ambiguous case, or case 2, tells me that this might not be possibly a triangle. Maybe this doesn't actually form a triangle. Or it might form a triangle, or I could maybe form 2 triangles. And so that's why it's ambiguous in this case. It's unclear whether I've got a good triangle drawn or not. So we're going to use law of sines, and we're going to notice the connection between a side and an angle. It's apparent that we would find angle A first. Looking at the information that I have given, since I've got this side A would match up with angle A, I'm going to put those 2 together. Okay? Now, don't write this down. We know that the law of sines from yesterday says something like this. But since I'm going to be solving for this angle, I don't want my variable to be on the bottom. It adds a step to my solving process. What I'm going to do is just completely flip the equation upside down. And I'm allowed to do that. And so I would put this equation, just write it upside down. Because I want the variable that I solve for to be on the top. Trust me, it's going to save you a little bit of work. It's going to be a little bit easier to deal with. Okay, so let's look at this form of law of sines. It's just upside down. That's all it is. So let's fill in for what we've got. My missing variable is A, so we'll have sine of angle A over side A, 25.1, equals sine B, so that's sine 55.6 repeating degrees over side B is 8.94. So there's my proportion. You can think about it as cross-multiplying if you want, or you can think about multiplying both sides by 25.1 if you want. I kind of think about it as just multiply this up. But sine A is going to equal whatever we get when we multiply that side. So you need a calculator for this. And we're going to do 25.1 times sine 55.6 repeating divided by 8.92. And get about 2.318. So sine A equals 2.318437872. I don't really want to round off until the end of the problem. But I keep going. If I'm going to isolate the variable here, I have to do an inverse sine of both sides. And so we're doing an inverse sine of that number. I'm going to hit the answer button on my calculator so I don't have to round off or type in all those things. We see we get a domain error. Of course we get a domain error. This number right here has to be in between -1 and 1. We get an error which would indicate that no such triangle exists. No such triangle exists. If you get that same kind of error, it's telling you that there is no triangle.